What's up, Algebra 2? Here we are with inverse trig functions. Knowing an angle in a right triangle, you can use trig to find the ratio of the sides. If you already know that ratio, you can use inverse trig functions to find the angle. Alright, so from our setup here, from our angle theta, opposite is over here, that's empty. Across from the right angle is hypotenuse and adjacent. Okay, looks like we have hypotenuse and adjacent. Okay, so hypotenuse and adjacent, we're going to be using cosine. So cosine of angle theta equals 5 over 12. Okay, now if this was like 5 times x equals 5 over 12, you'd know what to do. You would do the opposite, or the inverse. Okay, we're going to undo it with cosine inverse. So cosine inverse undoes cosine, and we just have theta, angle theta. And we're going to do cosine inverse of 5/12 to come up with that angle. So we're going to type those in. It's exactly the same three buttons, sine, cosine, tangent. So second cosine, we're going to go 5 divided by 12. And we should get 65.37. If you're not getting that, I want to check what mode you're in. Mode, make sure we're in degrees. If you are in radians, you want to slide over to degrees and hit enter. It should jump over. Okay, second quit. And type it in again, and we should be getting 65.4. We'll just go to 1 decimal today. Alright, let's get you started on this one, and I'll let you go. So we have opposite. Hypotenuse doesn't have anything this time, so this is adjacent. Alright, what's going to use opposite and adjacent? We're going to go tan inverse. We'll save time. We'll just jump right to the good stuff this time, not go through all that. We're just going to do tan inverse of 7 over 7. You type it in and see what you get. Alright, hopefully we're getting a nice answer here of 45 degrees. Hopefully you recognize this triangle from geometry. Okay, a 45, 45, 90. The two legs are the same. We have a right isosceles triangle. Or an isosceles right triangle. Okay, third one's completely on you. Let's go ahead and push pause and give that one a go. Alright, welcome back. We have sine inverse of 3 over 12 for 14.5 degrees. Alright, sine inverse, 14.5 degrees. So if you want an angle back for an answer, that's when we use the inverses, the negative ones. If you are putting the angle in, then we use the regulars. Okay, this one looks a little weird. It is a little weird. Some of these other words will make more sense to you later on in the unit, but it fits. This problem kind of fits right now. We'll probably come back to these and do them again later on too. So find the exact value of all 6 trig functions if the terminal side of theta in standard position contains the point 3, negative 4. So that part probably doesn't make a whole lot of sense. But here's what we're going to do. 3, negative 4. Just roughly sketch it out, over 3, down 4. And we're going to draw a line segment from the origin to that point. Okay? Now we went over 3 and down 4. And we made a triangle. Use 4, not negative 4. We don't have negative distance. Okay, we didn't drive -4 miles. We didn't measure the tree to be negative 4 feet tall, okay? So 3 and 4. And our theta will always be right there next to the origin. Alright, so what you need to do is you need to do a little a squared plus b squared equals c squared, or maybe use your brain and remember something from geometry, a little shortcut, to find our third side. And I need all 6. Now I have sine, cosine, tangent already written here on the sheet for you. Do you remember the other 3, the partner 3? And then, using any one of these 3, can you do the inverse of those to tell me what the angle theta is there? So there's a lot to do. Missing side, all 6 trig functions, and then come up with the angle. Alright, push pause and give it a go. Thanks. Alright, let's see how we did. A little a squared plus b squared equals c squared. We should be getting 9 and 16 for 25. And when we square root it, we get 5. So our missing side there was 5. Also could have gotten 5 if you remembered your Pythagorean triples from geometry class. 3, 4, 5, Pythagorean triple. Alright, sine is opposite over hypotenuse. That's going to be 4/5. Cosine is adjacent over hypotenuse. 3/5. And tangent is opposite over adjacent. 4/3. Partner functions. Okay, the key here is that if one of them in each pair should start with C. So sine doesn't start with C, so I know cosecant is the one, CSC. And then we just flip that. 5/4. Cosine starts with a C, so its partner doesn't. SEC. 5/3. And tangent will flip to cotangent. 3/4. Alright, what is theta? Now you could pick any one of those 3 and do the inverse on your calculator. Let's do second cosine 3 divided by 5. 53.1. Second tangent 4 divided by 3. Okay? Any one of them, and we would have got 53.1 degrees. Ta-da! Alright, what fun awaits on the backside? Story problems. A golfer's getting ready for the next hole. The info card for that hole states that the hole is 5 yards above the height of the tee box and the angle of elevation is 3 degrees. How far away is the hole? So we got the tee box, we got the green, we got the hole in the middle. Alright? It's 5 yards above where we are teeing off from. So it's uphill, and that's uphill with 3 degrees incline there. Alright, so we can't go underground with the ball, so this is the way we want. Okay? So we have 3 degrees, we have opposite and hypotenuse. Opposite and hypotenuse, that's going to be sine. So we're going to go sine of 3 degrees equals 5 over x. Okay, this is one from yesterday when x is on the bottom. We can just flip-flop. X equals 5 divided by sine of 3 degrees. We got 95.5 yards. So just under 100 yards away, but it's 5 yards above, so it's an incline. Okay, and then they use that to figure out what kind of club they want to use. All right, one more. Sam walks 100 feet away from the Pride Rock entrance, turns around and uses his inclometer to record the angle of elevation, and it is 24.2 degrees. Use this angle of elevation of the peak, the tippy top of the Pride Rock entrance, and then add 5 feet for Sam's height, because he's like on the ground, but he's holding up his angle measuring device up to his eye. We'll just say that that's 5 feet above the ground. So that's 5 feet more you need to add on to the end. Okay? So we've got 24.2 degrees. We have opposite. Hypotenuse is empty, so we have adjacent. Opposite and adjacent with 24.2 degrees. And then we're going to add 5 feet to our final answer at the end. Okay, go ahead and push pause and see if you can get that one figured out. Alright, let's see how we did. We're going to do tangent of 24.2 equals x over 100. I'm going to multiply 100 up to both sides. Okay, and that's going to be 44.9 feet. And we're going to add 5 more feet for 49.9. What do you think? 49.9, 50 feet up to the top of Pride Rock, that peak right there at the front of school? I don't know. Maybe we'll have to go outside and do some trigonometry sometime. Alright, thanks for watching, kids. Good luck.